All right, here we go. We are looking at the abacus. Here's the abacus. Whoa. All right. So here's the abacus. Oh, and what we're going to do is we're going to do this number. We're going to do 1,000. Huh, interesting. We're going to do 1,600. No, we're not. We're going to do, oh, I know what I got to do. Sorry. Here it is. We got to figure out our numbers. That's what we got to do. All right. Whew. That was a rocky start. Hello, everybody. Hello. Hello, Joseph. All right. Good morning. Good morning. Good evening. Good afternoon. Good evening. Good evening. It's been a long day. So we're gonna do 4. We went 1, 2, 3, 4. That's what we're gonna do. Right, 1, 2, 3, 4. So on the abacus, we're gonna do 4. 1, 2, 3, 4. Now, if you look, then we're gonna do thousands. We're at the thousands. We're at 4,000 right here. So this is 4,000. How do I know this is 4,000? Well, this is 4,000 because if this is our ones, tens, hundred, thousands, that's what 4 is. 4 is 1, 2, 3, 4. We know what 4 looks like. So then 7 is the top bead, has a value of 5, and then we have 1, 2. So when we're looking, we know that 5 plus 2 is equal to 7. We have 4 again, so we have 1, 2, 3, 4. So on the abacus, we do 1, 2, 3, 4, and then what? We have 8. How do I know? We have 5 plus 3. 5 plus 3 is equal to 8. So we have 5 plus 3 is equal to 8. Thank you so much for liking my live. Thank you so much for liking my live. Here we are understanding how to read the abacus. An abacus is a counting tool. That's what it is. It's an abacus. Abacus. Counting tool. Counting tool. That's all it is. You visualize your number. Oh, that would be a good saying. Visualize your number. Visualize your number. Oh, that'd be good. So we got to look for 4,748. So we go 4,748. Okay, so that's what the 4,748 looks like. So we're going to color this in, and then we're going to go to our next number. Our next number is what? I'm gonna do that. Nate, thank you so much. Yeah. Thank you, everybody. Welcome. Thank you, everybody. Please keep your mind open to your. I'm sorry. Please keep your mind open.
Now, open your mind to me, please. Open your mind.
Oh, I wonder if I can get AI to do that for me. Visualize your number. Visualize your number. Okay, so we have 1 on the abacus. This is what 1 looks like. We have 6, 5, 6. That's where it came from. We have 2, 1, 2. So notice all the bottom beads a value of 2. And then we have 4. 1, 2, 3, 4. We have 1, 2, 3, 4. Thank you, everybody, for joining. What we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we will go into doing some adding and subtracting and multiplication. But the first thing we need to do is understand how to read the abacus. The reason why is because there's no point for me to be doing this and then you have no clue what the abacus, what the number is. So we have 1,624. That's what we're doing. So we got to find the number, and it goes like this. That's what the number looks like. 1,624. I'm going to color it in because that's what I like to do. I like to color. And then we have our next number. Thank you, everybody, for joining. Hello, my name is Lynette. We are reading the abacus, and this is made out of plastic. It is very easy to move, simple to use, easy to understand. We have 7 columns on the abacus. 1, 2, 3, 4, 5, 6, 7. It is made out of plastic. Now, you'll notice that the beads are very easy to move. Because they're easy to move, you need to stabilize it. Use your left hand to stabilize it, and use your right hand to do the calculations. Why? Because the left brain's connected to the right hand, and the right hand's connected to the abacus. All right. Okay. So for those of you that are interested, we are learning how to read the abacus. We have we have this number. This number on this picture is what we need to figure out. So we have 7 here. How do I know it's 7? Because it's 5, 6, 7. 5 plus 2 is equal to 7. This is 0. Why? Because none of the beads are touching this horizontal bar, this reckoning bar. Because none of the beads are touching the reckoning bar, none of the beads are being counted. So what happens? We have these 3 beads connected to the reckoning bar. This reckoning bar is what counts the beads. So I'll do 1, 2, 3. Then we have 4. How do I know? Because I have 4 beads. All the bottom beads has a value of 1. 1, 2, 3, 4. If I added the 5, we would have 9. Okay? But I'm not adding the 5. If I add the 5 here from the 3 to 5, 3 plus 5 is 8. So, but that's not what we're looking for. What we're looking for is our number 4307. This is not 3. Why? Because we have the top bead touching. The top bead is a value of 5. The top bead is our reckoning. The top bead is a value of 5, and it's touching our reckoning bar. This is why this is 7. Thank you, everybody, for joining. Thank you, everybody, for joining.
Now, open your mind to me, please. Open your mind.
So what my goal is to do is to show the abacus, show the matrix what the abacus is. And you guys are all part of the abacus. Hello, JJ. That's 7. You're right. Thank you, Brenda. It is 7. I got confused. Yes, it is 7. It is not 3. It is 7. You're absolutely right. Thank you so much, because we have 5, 6, 7. Oh, wait. I never thought I'd be able to read the abacus. Oh, we should do that. Thank you. Thank you. Thank you. Thank you. Did that work? There we go. There we go. Good job, Brenda. So our next number is what? We're going to do 0 here. Why? Because there's none of the beads are touching the reckoning bar. I love your class. Hello, Miss Gina. Because I'm being silly. Thank you so much. Thank you so much. I will be here all week. So we have 3 on the abacus. We have 1, 2, 3. I don't think this is the type of energy people are looking for in the middle of the night. I'm just saying. I'm just saying. Okay, what's next? Well, this is 0. Why? Because none of the beads are touching the abacus. And then our next number is going to be 5. Remember that the top bead is a value of 5. We have the 5. So we have 300.05. Well, it's a 4-digit number. What? Is it really 4 digits? The first one is 0. Don't forget to tip your abacus. Yeah. Thank you so much. Thank you so much. That's a good one. That is a good one. I will have to make a note of that. So we're using 4 digits. It's supposed to be 4 digits, but you can still have 3 digits. And when we use 3 digits, we want to be able to use our 0 as a placeholder. So we still have 300.05. So our answer we're looking for is 300.05. And it takes us up to here. I'm going to keep doing this. It takes us up to here, right? And then we have our next number. So our next number is what? We have 5 on the abacus. We have 9. I know this is 9 because all of the beads are touching the reckoning bar. And again, all of the beads are touching the reckoning bar. 5 plus 4 is equal to 9. 5 plus 4, right? 1, 2, 3, 4 is equal to 9. And then we have 5 plus 2 is equal to 7. That's simple. I know it's simple. I'm just showing you how to read the abacus. Once we figure out how to read the abacus, then we'll go into doing some more complicated adding and subtracting. But the first thing to do is understand how to read the abacus. So that was the number 5,997. This book will be available. Not yet. I got to put it up in there. Hello, Ada. Thank you. Yes, good. I'm so happy. You are my people. I am here to show the matrix what an abacus is. Thank you, everybody, for joining. Thank you, everybody, for joining. Please keep your mind open for something different. It is not new. It's not new. It's pretty old.
Now, open your mind to me, please. Open your mind.
How old is it? It is so old. It was around before Christ. Mesopotamia. They say that the first time they used the abacus was before it was 500 BC. So the first thing we're going to do is we're going to do 1, and then we do 8. We have 1, and then there's 2. We have 1, The top beat is the bottom beat is a value of 1. These are all values of 1. So this is 1, this is 3, this is 1, this is 2. Now, when we add the top beat, it's 5. So here we have 1, 8, 1, 2. Oh, Joseph, thank you so much for the question. Why? Why? Oh, because I have the ones place right here. The ones place is my label. If you notice there's a little dot here, this is my marker. This marker tells me that this is my ones place. So when I look, after the ones is the tenths. The decimal actually sits between the ones and the tenths. Does that make sense, Joseph? Thank you for the question. That is a very good question. The reason why I do that is because I want to make sure that you're actively learning and not passively watching, because this is more interactive. I want to be interactive. So when we're looking, right, does that make sense? Now, when we have it, we can, thank you, Couches Lounge Gaming. Thank you so much. So, woo, thank you for the, okay, so if you notice, we have another label here. This one tells me that this is the thousands, just like how we have our commas. Let me show you. Just like how we have our commas. So if I had the number 55,000, see there's a comma there? 555.55. What happens if the number goes higher than the abacus goes? Haha, Melanie. Because you got to get a bigger abacus because size matters. This is a 13 column abacus, and we don't want to talk about sizes, but it does matter because the more digits you have, the more digits you need for your columns because every column is represented. So you can't just compound each other. You can't use bunk beds as an abacus and all be buddies and we can watch TV and all be buddies. No, you can't do that. Oh my God, that'd be funny. Bunk beds. I gotta write that down. Bunk abacus. We can't do bunk abacus and just be buddies. I'm getting epiphanies. How is she so? Hello, Titan. Good evening, good morning, good afternoon.
Step 2, greet the day, smile, and say, Good morning, city!
Okay, so going back to the question, we have our ones. This is the marker for the ones, and then we have our thousands. Now, if you notice that if I did this, this is 99,000, right? With our zero and our period, our decimal, and then 00. So you'll notice I have 99,000. Well, what happens if I can choose this one? Hello. Oh, thank you. Thank you. Thank you very much. So here, if I decide to choose this one over here to be my ones place, right? Just like a Pokemon, just choose one.
Pokemon, I choose you.
I choose this one, then this will be my ones place. I move everything over and everything would be like that. Oh, I can't see. There we go. So we have our ones, right? We have our ones. This is our ones. This is our tens. This is our ones. This is our decimal. Our decimal sits between our two columns, right? It doesn't take a placeholder. So we have our tenths, hundreds, thousands. So we have our one. We have our tenths, hundreds, thousands, thousands, 10,000s, and then 100,000s. Then I can add my one there. So now I have a really, really, really small number. That's what you could do. So it doesn't matter where you choose your ones place to be. You just need to choose one. That's it. So I like to use this one because then I have more.
Okay, Charizard, I choose you.
Because then I have more room. So if I move, then I'd move everything over. And then I'd have everything up to 10,000. So, Melanie asked, well, what happens when there's not enough? Well, that's what happens with this. So I don't know how big your numbers are going to be, but you could use this one here. This one, if I choose this one to be my ones place, if I want to choose this one to be my ones place, then I have my thousands, and then I have my millions. However, thank you, Joseph. Oh, thank you so much, Joseph. Thank you so much. I'm going to pin that one. I gotta be narcissistic. I'm going to be narcissistic and add it, right? I don't know what that really means. Anyways, so thank you. So we have our ones, our hundreds, and our thousands. And then if you notice, if you say you wanted a bigger number, well, that's fine. You can just take the ones over here. So then it'd be ones, thousands, millions, and then billions. Well, okay, well, what if I want to talk about trillions? Okay. So if you want to talk about trillions, just go over here. So then I have my ones, thousands, millions, billions, and trillions. Okay. What happens? What happens when there's more? Well, you need to get a bigger abacus. You get a bigger abacus. This is a 23 column abacus. However, I do not sell this. I only sell the 13 column abacus because I think the 13 column abacus is sufficient. How do the individual numbers work like 1, 2, 3, 4, 5? Very good question. Hi, I motives. Well, thank you so much. Thank you so much. So let's do that. So we have 1. That's it. I'm done. 2, 3, 4. So then we have the top beat as a value of 5. That's what that is. So we have the top beat of value of 5. You'll notice if I do this, I have 1 again. I'm back to 1. Well, what happens? Well, what happens is I can do 5 plus 1 is 6. That's what I could do, right? If I did 2, remember this is 2. Remember that this is 2. I sometimes slur. Remember this is 2, right? If I add the 5, now we have 7. So we have 3, 1, 2, 3. I add the 5, now we have 8. We have 4, add the 5, we have 9. Well, what about 10? Well, we know what 10 is. 10 is a 1 and a 0. 1 tens and 0 ones. That's what a 10 looks like, right? And then we have 11, 12, 13, 14, and then 15. That's it. Bada bing, bada bing, bada bam. I don't know if I said that right. Bada bing. I don't know. That's all I know. I have to get my quotes better. All right. So what's next? We're going to keep going. We're going to keep going. Thank you. Somebody said 1812. Thank you, couches. Thank you, couch. Yes, couch, lounge. Thank you. Yes, that is correct. So what is our next number? So we have, right? What we're doing is we're trying to read the abacus. Bada bing. Thank you, Miss Gina. Bada bing, bada boom. Yeah. Thank you. Hey, there's Robert. This friend is now live. Okay, so 15 would be 15 is 1 and a 5. 3 blue. No, it wouldn't be 3 blue because this would be 555. This would be 555. 15 would look like 1, just as you typed 1 and 5. Every number is represented. Every number is represented. When we look at the number, we have 9. Every number is represented. If we have 8, that's what 8 looks like. If we have 7, we have 6, we have 5. Now we're counting backwards. We have 4, we have 3, 2, and 1. So no, this would not be 15. We're not adding these because it's a different way of thinking. Why? Because in mainstream, my arch enemy, the mainstream. No, mainstream math, what do? There's a 1-to-1 situation, right? There's a 1-to-1. So if I just combine all these together, then you would add it all. But that's not what we do in Abacus. And what we do with Abacus is a representation. So if I did 5, right? This is 5. 1, 2, 3, 4, 5. But on the Abacus, this is 5. So yes, exactly. So we have 1. That's what 1 looks like. 10 looks like that. Notice I changed the number. This is 10. Then we do 20, 30, 40, and then 50, 60, 70, 80, 90. Thank you, high ire, right? So when we're looking, thank you, Grace. Yes, it is 2,590. It is not 7. It is not 7. 7. It is 8, actually. You're right. So we have 2 on the abacus. This is the thousands. And then we have 5, which is the top bead. Then we have 9, which is 5 plus 4 is equal to 9. And then we have 8. 5 plus 3 is equal to 8. That's it. Eddie, what are the furthest 2 numbers represent? Those are the dots. No, those are the decimals. So after, just like how we write. Oh, higher motives. Spelling. Oh. Okay. I was like, what's a high I? Yes, Grace. Yes, exactly. So these 2 columns right here is the decimals. We have our tenths and our hundredths. I see. Spelling, spell. Mathing, math. Abacus, math. No? Abacusing. I'm abacusing. So the two more, yes, exactly. If we choose this one to be our ones place, notice that there's a label here. This is our ones. So what we're doing is we're labeling this as our ones place. So after the ones, our decimal sits between. Our decimal doesn't sit on a column because it doesn't take a place value. It sits in between the ones and the tenths. So you're right. So after that will be our tenths and your hundreds. So that's what we have. We have 2,598. 2,598. There we go. So what we're doing is we're learning how to read the abacus. So the dot represents the ones place. No, does not represent the decimals. It's one or the other. It does not represent because it's the ones place. The decimal sits between the ones, just like how we do our numbers, right? We have 328.89. This does not take a placeholder. This is not a place value. The only place values you have is ones, tens, hundreds, right? Then you have your tenths and your hundreds. This dot does not take it into a placeholder. So when I represent it, it would be 3, 2, 8, 8, 9. That's what that would look like. The marker is different than the decimal. Don't combine the two. Okay, so yes. If I had 9999941, yes. So it'd be 14,999.99. How would you do a math problem? I'm still answering questions on how to read the abacus, Eddie, but we can get there in a little bit. Let's put a pin in that. Boop. No, like, you know where your thousands, etc. What am I looking at? No. My decimal sits right here. Oh, okay, right. Okay, so yes. Yeah, no. If you want it to be more, then you go here. So then, see how the decimal still sits between the ones and the tenths. So if your decimal if your one sits here, your decimal sits between, then you have your tenths, hundreds, thousands, 10,000s, and then you have your 100,000s. I get it, sorry. I don't know how to explain it, but I'm understanding now. Okay, good. All right. So, I need that. I need to put this away. Yeah. So, we're going to continue on. We didn't do this one. I've never seen a decimal on an abacus before. Would have made it easy. Yeah. It would have made it a lot easier if you can actually visualize your numbers. That's all we're doing with the abacus is just visualizing our numbers. So we have 1,152, right? Okay, so we're going to do 1,152. That's what this is. Okay, you guys let me know what is the next number. What number is this? You let me know. I found it under the... Okay, so we have our thousands, we have our hundreds, we have our tens, and we have our ones. What? Get it? Got it? Yeah. Who was that? Get it? Got it? Good. Was that like Pep Boys or something? Thank you, Savannah. Yes. So it's 1,600, 0, not 1, 5. Thank you, Savannah Rain. Yes. Thank you. That's what it is. Wow. You guys. I don't know what you guys are doing. What? Okay, yes. 1,600, 5. There is no 001. I understand. And all my 52. I would never understand, but I do now. Great, Patty. Thank you so much. Yes, thank you, Zenith Phoenix Photography. Oh, that's funny. That's an interesting name. Thank you. Joseph, yes, thank you, Joseph. Hello, Sarah, welcome back. Thank you, Melanie. Grace, does this understand? So we have our 1, we have our 6, 5, and then 6. 5 plus 1 is 6. Hello, Amy. And then from the court jester. Is that what it is? Get it? Got it? Good. Oh, okay, I'll have to get that. Haha, tempted. So we have 0 and then we have 1. Welcome back. Welcome back. I don't have that. I don't have a welcome back. I don't have welcome back. I need to add that to my list. Welcome back. That'd be good, right? All I have is this one.
Welcome to the real world.
Okay, so I'm going to color in my abacus. I'm going to do 1. I'll do 6. I have 0 and I have 5. What would be welcome back? Welcome back. Welcome back. I don't know. I have to figure that one out. I need to find a movie quote or something for welcome back. Hello, Nate. Thank you. I wish my kids think I was cool. So we have our number. You let me know what number this is. What number? Thank you so much for the ice cream cone. Ice cream cone. Ice cream cone, and it's corn. Got it, tempted. Got it. Luke, I'm your father. Kind of like that, but not really. Yeah, kids, right? Right. I know, but it is what it is. That's all right. I feel a little dumb, and I will embarrass them. I'm okay with that. So, what's our next number? That's what it is. What's our next number? Yes, thank you, Patty. 1092. Thank you, Patty. Thank you, Melanie. Thank you, Joseph. I'm going to. Hello. Your kids probably think you're the coolest in secret. One can only think. All right. So we have, yes, it is, why the abacus? Why the abacus? Yeet. Why yeet? Yeet. Canon. Yeet. I don't know what yeet means. Yeet sounds like beat. Beat and geet. Oh, geek. No. Yes. Right, Patty? Simple to use, easy to understand. Thank you. So what's our next number? What's our next number? We have this, and we have that. So we have our thousands, our hundreds, our tens, and our ones. Oh, that doesn't look good. I gotta do it this way. There we go. Okay, yes, thank you, tempted. 8,374. Well done. I gotta do that. Okay, how do you use one? I've never used one before. We need a gooning like gooning, like Goonies? Like gooning? I don't know what that means. Chill, Dawn. Chill. Okay, 53 if I. Oh, good. Nah, I did, tempted. Thank you so much. All right. Yes. So we have 8,374. Please don't say that. Chill. Head out. Deaf. Good. Oh, hey, good. See you later, higher motives. I got my book. Thank you so much. Love doing the puzzles. New addiction. Good job. Yeah, right. I was trying to make puzzles, and I was trying to make it fun, and I wanted to make it interactive for everybody, because I believe that I'm spreading the good word of the abacus. So what are we doing? We're learning how to read the abacus. After we learn how to read the abacus, we will start to do some adding and subtracting. But the first thing we need to do is, you tell me how to use the abacus. I'll forever remember you. Thank you, tempted. I do appreciate that. I appreciate everybody joining and learning. I do find it the greatest thing next to sliced bread. And no matter how many times that I know how to count from 1 to 9, I still find it fascinating to be able to show everybody how to read the abacus. It's funny. I've been doing this for 20 years and I still enjoy it. Thank you, Patty. Thank you, Melanie. Thank you, Sarah. And that's it. So this is my worksheet. This is a worksheet that I've created, and what we're doing is we're learning how to read the abacus. Now, is it possible to do fractions on the abacus? Well, what's really fractions? Fraction is another type of division. Can you add the fractions? No, you can't. No, the limitations to Abacus is only doing basic arithmetic, only basic adding, subtracting, multiplying, and dividing. That's the only thing. We can do division. Yeah, we can do division. What we do in Abacus land, in Abacus world, we do long division, and there's a process to it, but we do long division. It is possible, and we also do multiplication. I don't know how. I don't know how many people. I don't know. When those people that do take abacus classes, how far they go. But but it does sound like they only go as far as adding and subtracting a lot of numbers. Whereas in abacus you can do multiplying and dividing. Okay. So for those of you that are here, thank you so much for joining. Thank you so much for joining. Please keep your mind open to something different because it is different, but it is not new.
Now open your mind to me, please. Open your mind.
Thank you everybody for liking the live. Thank you so much for liking the live. And so when we're looking, and so when we're looking, this is a book that I have created. This book was meant for preschool kids. And those are the kids that are trying to learn their numbers and so forth. The reason why I wanted to start them young is because in Abacus world, we actually didn't start them young. We usually start the kids at about 5. They should already know their numbers. But I feel like that if we just made it like fun and interactive, then I think the kids will be able to understand how to. Oh, my niece is in preschool. Her first day. Oh, yay! Her first day was she scared? I hope she wasn't scared. Yeah, I hope she had fun. Oh, I love preschool. And so, what I did here was I created activities to just strengthen the concept of how to read the numbers from 0 to 9. And so we do 0 to 9. Oh, she wasn't scared. She had a lot of fun. Oh, that's so good. Hey, she takes naps still, doesn't she? Yeah. Those are the best ages. And then they play in the playground, and I have so much fun memories for the boys. Yeah. That's so good. Yeah, my middle one didn't like my middle one didn't like preschool, and it was sad because I had to he had to be pushed into preschool early because I had my third kid, and I didn't want to overwhelm the nanny. I had a nanny. Naps. Is that what she talked about? The naps are the best. My middle one didn't like naps. He did not like naps. Okay, so then lesson 3 is counting forward, and lesson 4 is counting backwards. Then lesson 5 is understanding the relationship of what's becoming in between. And so, if you have the number here and you have the number here, you need to let me know what the number in the middle is. And then we start talking about what's the number comes before and what comes after. And then after that, we talk about comparing, and that's it. No, that's not it. Then we get into understanding how to add and subtract. So in in Abacus world, what we do is we learn how to look at the numbers. When we look at the numbers, I didn't get to go to preschool. I went straight to kindergarten. Oh, you're lucky. You're lucky because I had to send my kids out because I was working. You know what I mean? So you're very lucky if you were with your mom or with your family before you went to kindergarten. Was it traumatic? Was going to kindergarten traumatic for you? Because you went from home to school? That's what I wonder. Hello, Tammy. Hello. Oh, I got some new songs. In Abacus world, what we're going to do is we're going to understand the second number. The second number is what tells us whether or not we're going to. No, I made friends with everyone. Oh, that's really good. That's really good. That's really good. I don't remember anybody in my preschool, but I'm also really old. So, we're going to do 7. So here's 7 on the abacus, and we're going to add the 1. Can we add the 1? Yes or no? Yes, we can. So we're going to add the 1, and our final answer is 8. Notice I'm not focusing on you seem like late 20s. I wish. Yeah, no. No, I have to ask my kids what are acronyms. What some of the words that they have that they're using. So yeah. We have our next number. So if we're looking, we have 7 on the abacus. When we're looking at the second number. The second number is what's going to tell us whether it's going to be a using a formula or if we have enough beads. So when we're looking, we have enough beads. Yes, we can. We can add the 2. And we have 9. 5, 6, 7, 8, 9. Preschools were not a huge thing back in the day. Oh, that's probably why. Yeah, that's probably why. I know I went to preschool because both my parents had to work. You know, back in the day, I was living in a household that was a 2-income family, and it was, it was tough. First immigrated to Canada and then trying to survive. It was really tough. So it is what it is. Okay, so our next number is going to be 5. So here on the abacus, we add the 5, and then we add 3. We're going to do 1, 2, 3. And then my final answer is 8. So then our next number is here. We do 5 on the abacus. Oh, I did that. And then 3. So what we could do is we could subitize. We could look at this number, we could subitize. We could say that this is 8. How do I know? Because we have 5, 6, 7, 8. So in mainstream, you can do dots, which is fine. You could do dots, or you could do, and that's a whole lot of counting. Or you could do tally marks, again, which is a whole lot of counting. But in abacus, we don't need to use the dots because we just use our beads. So we can do this. We can do add the 5 and add the 3. Now, if you notice, I can actually scale it. What if I wanted to do 50 plus 30? Now I have 80. See that? Because why? I have our 1s and our 10s. But if you did it on the dots, if you had to do all those dots, that's a whole lot of dots. That's a cheek ton of dots. And so when we're looking, we have our 50 over here and we have our 30. And then you have to count it all. What if you don't know how to add it? Then you have to count everything. Whew, that's a lot of counting. We could scale this up one more. We could do 500 plus 300. Notice that I could do 500 plus 300 is equal to 800. So we have 800. So if you notice, if I add, we go to the horizontal bar. So here, I'm having 5 on the abacus. I add 4. To add the 4, I go to the horizontal bar. When I subtract, I go away from the horizontal bar. So if I have 9 on the abacus, I want to take away 1. Right? All I'm doing is take away the 1. I'm not taking away this 1. I'm taking away the bottom 1. I'm only need to take away the 1 bead. If I have, it doesn't matter which bead I take away, as long as it's 1 bead. So if I have 8, I take away 1, right? If I have 7, I take away 1. If I have 6, I take away 1. That's how this works. And so when we're looking, that's what I did with the -1. And then we could do it again with the -2, right? So we have 3 on the abacus. I want to take away 2. I'm taking away just 2 beads. It doesn't matter what 2 beads. It could be these 2 beads, these 2 beads, or these 2 beads. Even if we had the 5, it'd be the same thing. These 2 beads, these 2 beads, or these 2 beads. So after 5 is, after minus the 2 is minus the 3. I have 4 on the abacus. That's what I got. I got 4 on the abacus. I want to take away 3. 1, 2, 3. And so my final answer is 1. That's it. And so we can keep going. So now we already know how to minus, because what do? If we know how to add, we know how to subtract. So notice I add, I go to the horizontal bar. When I subtract, I go away from the horizontal bar. So if I have 5 on the abacus and I add the 3, I go to the horizontal bar. My final answer is 8. So it's the same thing with the 6. If I have 1 on the abacus, I want to add the 6 or I take away the 6. So notice you're going to see a number pattern. I add the 6 or I take away the 6. I add the 6, take away the 6. We could do it again with the 7 or the 8. Here's the 8. So we have 1 on the abacus. I have 8 on the abacus. I add the 8. I take away the 8 or I add the 8. That's all we're doing. Thank you, Cassandra, for checking in. Thank you, everybody. Please go ahead and check in. There's an orange heart me on the top of my head somewhere. Please go ahead and check in for those of you that are keeping up. And then that's it. So we same thing with the 9. 9 is all together. 9 together, 9 apart. 9 together, 9 apart. That's it. So that's it. This is the preschool book. This preschool book is just for preschoolers. I think it'd be too young for anybody who is in first grade and higher. The reason why is because I was trying to get the children to understand the relationship of the numbers. That is why I created the Preschool Abacus Math Book. So now what's next? Well, we can do what? We can do some more adding and subtracting. Because what's going to happen is, well, what happens when there's not enough beats? Well, here is a number. This question is 4 plus 4. 4 plus 4, we know it. No, 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 no. This way, this way, this way. What we're going to do is we understand 4, right? And we want to add another 4. To add another 4, what are we going to do? This is what we're going to do. We have 4 on the abacus. We have 4. Thank you so much for checking in. Thank you so much for checking in. So we have 4, 1, 2. Oh, thank you so much for checking in. All right. So we have 4 on the abacus. This is the 4. 1, 2, 3, 4. We have 1, 2, 3, 4. Now what are we going to do? We have to add another 4. To add another 4, we don't have any more room. We have no more room to add another 4. So that's why we have to utilize the 5. Thank you, Cassandra. We have to plus the 5 and then take away the 1. That's what she did. Yep, exactly. Thank you, Chris. Thank you, Cassandra. And that's what we need to do. Why? Because even though we're adding, we need to subtract. Why? Because we're adding too much, right? Just like when you're drifting. You drift, you're going too fast.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So what are we trying to do? So on my abacus, I add the 5 and I take away the 1. Why? Well, the reason why is because I have so many beads. If you notice, if I have 4 on the abacus, 1, 2, 3, 4, right? And I want to add another 4, I'm going to give you this package of 5, just like this nickel. But you can't break this nickel apart. You can't break the nickel. So that's why we use this to help visualize that I don't need this one column, this one cube. But because it's attached, I have no choice but to remove it from the 4. So that's why I minus the 4. So then we could do it again. We're just practicing how to add the 4. If I have 3 on the abacus, right, and then want to add the 4 isn't here. 1, 2, 3, 4. But notice it's too much. I need to remove this one cube. But just like a nickel, you cannot remove this penny from here. So what's going to happen is you've got to remove it from the first number. The first number is the loose bead. So we take away it. And so our final answer is 7. 5 is 4. So if you want to add a 4, you don't have that. You just don't have to just add the 5 and take away 1. Not what? You can't. What? Why am I more confused?
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Why? Because if you look at the abacus, we don't have any more room. So that's why when we want to add the 4, we have to add this 5. We don't want to add 4 here because that's just 44 or 43. You don't have to just add the 5 and take away the 1. So if you want to add the 4, yes. If you want to add the 4, you got to add the 4 to the 1s column. The 1s column, oh, thank you so much for the Pharaoh mask. Does that make sense? So what we're doing is, thank you, Cassandra. So what we're doing is we are looking at this 1s column. Because we're looking at the 1s column, we can't do anything else. We got to figure out how to add everything to the 1. We don't want to count up, right? So that's what mainstream math does. And that's why it's confusing, because there's no concept of because we're trying to understand a concept. This concept is what? I'm going to get this. Yeah. Oh. Wait, I'm going to get. So this is the concept that we're trying to do. 4 plus 1 is equal to 5. We know this concept. Oh, I see. I'm going to get some sleep. Okay. I'll see you in my next live, and hopefully I'll be on a little bit earlier, so it'll be easier to understand. Because we are doing it in the middle of the night. Excuse me. Oh, so when you're looking, right, what we're doing is we're understanding this concept. There's a 4 plus 1 is equal to 5. Well, what are we doing here? What we're doing here is what? It's just an addition sentence. But what we do is we just modify it. We do some modification.
You need modifications! Modify! Modify!
So in this one, and it is, which one is it? Um, oh, here it is. Yeah, number 14. So here, it kind of goes into explaining what the formulas are. So there's a bunch of formulas in Abacus World that we need to do. Thank you for the follow. I remember I learned Abacus formulas where you something's cat and the mouse. Yes. Yes. That's in division. That's division. Where there is a cat and it eats the mice. And then there's a cat bigger beside in CBB. Are you in LA? Did you come from AMA? Was your teacher Mr. Jeremy or Miss Karen? All right. Oh my God! You were one of our students. Because that's what we taught. That's division. we're still in Monterey Park. Yeah. Yeah. What year were you in? What year were you there? We're still there. I remember Miss... No, not Helen. Miss Annie. There was Annie. No, we didn't have a Helen. It wasn't Helen. It's Karen. She's still with us. Miss Karen is still with us. And then Miss Jennifer. I don't know if you know Miss Jennifer. There was a Vivian. Welcome, welcome. Do you? Yeah. So you were in Alhambra. Too long I have to see. Thank you for the follow. Yeah, we're still around. We're still around. We still have a few kids. I'm trying to show the Matrix what the Abacus is. And I've got books. I've got books. I've got books. Because, Alex, why are you so judgy? I've got books and I made it more better. So we're actually I'm doing activities. These are all my activities. Wow. Wow, Alex, you're so judgy. That's interesting that your profile picture is a anime. Japanese anime. So, I don't know. You could just be a poser. You're a poser. Because I like anime. And then you're just a poser. Maybe you're a wigger. I don't know where you are, and that's very racist. So you can either step off my live or just move on because you don't need to be here. You don't need to be here. All right. So, where was I? Yeah. So cat and mouse is because we're doing division. Oh yeah. So, okay. So what we're doing is we're understanding that we're taking the 4. We have 4 plus 1 is equal to 5, right? Because we have 4 plus 1 is equal to 5, what we want to do is we want to isolate the variable. When we isolate the variable, we're going to be utilizing this 5. This 5 is going to be our constant. So when we're looking at it, it's going to be very similar to algebra. Why? Because we have constants and this actually changes. So when we go to the 3, you'll see that there's a lot of similarities. So when we have it, and why are we doing it, is because I want to add the 5. I need to add the 5 to the top. I need to add 4. But to add the 4, I add the 5, just like how we have the nickel. But the problem is the nickel, you can't break it apart. Because you can't break it apart, what happens? You got to remove it with one of the pennies. That's what you got to do. So just like we do here, right? We have 4, but to add the 5, to add the 4, we need to take away the 1. You should go get some Advil or Tylenol. That's kid safe, right? Advil. Or it could be a caffeine headache, and you might need to drink more caffeine. Because I'm sure that the kids drink a lot of Red Bulls or whatever energy drinks. What else would give you a headache? Too much alcohol would give you a headache. But you're too young to have alcohol, so no. Don't drink alcohol. No. No. What you should do is you should either, get rid of the caffeine headache or you should take a nap. That's what you should do. but the problem doesn't. What? Maybe he needs an aha. Yeah, maybe not enough, right, Chaotic? Not enough water. Oh, not enough electrolytes. Yeah, we need to have some salt water. Okay, so what are we trying to do? We're trying to figure out what this thing is. Please, everybody, keep your mind open. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Thank you, Chaotic, for the Pharaoh mask. So, what are the other beats for? The tenths and the hundred? Yes, it is. It is. It's exactly what it is. It's the tenths and then the hundredths. Because this is the ones, just like how we write. We have our ones, tenths, and then hundredths. So when we are looking at this would be, what number would this be? So please put in the chat what number you think this is. Yeah. What number do you think that is? On the abacus, what number do you think it is? Just because you seem nice, I won't bother you. Dingo. Thank you for being nice. I like to cook. I like to cook trolls. Thank you, Chaotic. Thank you, Chris. Yes, it is 98. So when we're looking, we have the 5 on the top bead, right? The top bead is a value of 5. They're touching the reckoning bar. Because they're touching the reckoning bar, these are being counted. So we have 9 and we have 8. When we're looking, the bottom beads is a value of 4. We have 1, 2, 3, 4. So we have 5, 6, 7, 8, 9. 5 plus 4 is equal to 9. And then we have 5 plus 3 is equal to 8. So that's what that looks like. I don't know. I'm going to keep going. So what we're trying to do is, that was a little bit about that. But one of the things here is trying to understand how this concept works. The concept is, what we're trying to do is, if we have enough. We don't have enough to, hello, no! Hello, no! Welcome, welcome, welcome. So we're going to go into 3. The same thing, right? We're not going to memorize our numbers. We're not going to memorize that 3 plus 3 is equal to 6. I'm getting it slowly. Okay, good. I'll keep going. I'll keep going because it's good to just see the different, different examples. You'll get it. I know you will. It just takes time to get the different examples. Thank you, Ismail. So, when we're looking, right, what we want to do is we want to add the 4. Notice I have no more room to add the 3. So guess what? When we add the 3, we know to make a 5, it's a 2. To make a 5, it's a 2. Right? This is the concept. Why? Because this 3 is this 3 right here. So what we need to do is we need to do some modification.
You need modification! Modify!
So if I have 4 in the abacus, right, and I want to add 3, you'll notice I don't say long. Oh, hey, I just got my friend. Oh, thank you so much for the heart. Thank you so much, Chaotic. Thank you so much. Thank you for the rose. Oh, thank you. I appreciate that, Chaotic. Yeah, so we have 4. So then what we're going to do is we're going to add the 3. When we add 3, you'll notice that we can't do it because I'm going to have to give you my 5. My 5 is plenty. Oh, thank you so much. Thank you. Yes, Chris, it is right. So if I give you my 5 if I give you my nickel, my 1 5 cents, right? That's way too much. So if it's too much, I need to do what? I need to extract 2. So I have to minus the 2. I have to bring down the 2. So on my abacus, I can add the 5 and then take away the 2. Hello, Robert! Hello, Robert. How are you today? Welcome, welcome, welcome. Yeah, I saw you went on live today. Well done. Well done. So does that make sense? Mew? When we're looking, what we need to do is we do it again. So I have 3 on the abacus. Mind blown. Oh, this one. Where is it?
Oh, I can see everything.
Yeah. See, once you see the concept of this 5, right? Once you see it, you can never unsee it. So because I have 3, right? and I want to add the 3 again, but I need to replace it with this 5. That's too much. So I have to take away the 2. So my final answer is 6. Facts. So I could do it again on the abacus. I have 3 on my abacus. 1, 2, 3. I add the 5 and then take away the 2. You laugh. But it's true. I just finished my live about 30 seconds ago. Oh, good. Oh, so good. Oh, go so good. Oh, Josh, you're so not good. It is, there we go, reported. Okay, so, Mew, do you see that? So we're going to do it again. So the other thing is what? Is also doing practicing. So we're practicing to see how we're doing it. Every number, you'll notice that you'll be able to do a lot more once you understand how to add the 3. When you add the 3, I'm going to give you this 5. That's too much. I need some change back. In order to get some change back, I need to take away the 2. So my final answer is 5. So I have the 5 and I take away the 2. And it's the same thing with the 2, right? But this time I only have 2 questions. When we do it, right, we have 4 on the abacus. Remember, if I'm adding 2, what do? If I'm adding 2, I have to take away the 3. That's what I got to do. So I have 4 on the abacus. I want to add the 2, right? I'm over here. I want to add the 2. I have 4 on the abacus. I add the 2. And then what do? I have to, too much. I have to get my change back. I have to take away the 3. Right? So I can do it again. So now I have 6. So I can add the 5 and can take away the 3. And so I have 6. Yep. And so what happens? Oh. We can do it again we can do it again one more time. Right? Because it's only because you don't have enough. So I have 3 on the abacus, and then I add the 5, right? That's too much. Because it's too much, what do? I have to take away the 2. So, oh no, I have to take away the 3. So then my final answer is 5. So that's what we did. Because what do? We know that if we have 2 plus 3 is equal to 5. What we're doing is we're balancing the equation. That's what we're doing. We're balancing the equation. That was really crazy. I just saw a student It's not my student, but I saw a student. That was crazy. Thank you, Alvarez, for the follow. So, squish. Okay, so what we're doing, let's do a little review on how to read the abacus. So we have, can you do large numbers? Yeah. 99,999.99. That's my largest number on this abacus. So, squash, we have 1, 2, 3, 4, and then 5. Oh, you're still here, D-Pan. That's funny. Yes, we could also do decimals. And then the decimals can, yeah. So we have 5, and then we have 6, 7, 8, 9, and then 10. So then, D-Pan, are you in college now or are you out of college? I do know a few people that actually went to Berkeley and they did some TED Talks and stuff. Thanks for the knowledge and a unique way of doing math. You're welcome, you. You're welcome. Mia, I got it, Mia. You're welcome. Welcome. Thank you so much for the follow. So we can do it again. And then this is not the only way, right? Because what's after this? After this we could do the plus 10s. Yeah. I graduated from college last year. Oh, that's great. You work at Edison. That's really awesome. How painful was Abacus for you? I have another person actually that comes by, but she's from a different school. And it was really interesting, like seeing what the other schools do. Yeah. Yes! When I went there, it wasn't any computer learning yet. Oh, you're old. Wow, there was a little bit, but mostly paper. Oh, yeah. Wow, that's a flashback. Yeah, that was so that was a wow. I've been teaching Abacus for about 20 years. And so we've been in business for 20 years. We still have it, but my dad decided to retire. Abacus, I remember that I kept forgetting the formulas, but I was able to do a muscle memory. Yeah. Hey, hello. Yeah, it's all about muscle memory. And that's the thing with my boys. They can't teach you But you know how to do it. Once you get the abacus, you know how to do it, and that's the idea. The idea is to do muscle memory. But once they took the abacus away, I was well, we still use, but you still use the. Anyways, yeah. So that the idea was to yeah, little paper abacus didn't work for me. Oh yeah, honestly, I still work with the abacus. I don't do it mentally. I don't do it mentally. My kids can kind of do it, but I don't push it. I remember we did back in the day. I remember we did that day. My hone has a calculator. Oh, I don't know if your hone would be a good thing to have a calculator, but the calculator is only as good as the user, and it doesn't seem like that blank is a very good user of the hone. Oh, I'm sorry, phone. I'm sorry, phone. Yeah, yeah. I see. I'm sorry. I didn't realize there was a typo on your phone, on your hone. I'm sorry, your phone. Right, right. And you can use a calculator, but as well as you type on your phone, I don't think you're going to be very good on the calculator either. I'm just saying. I'm just saying. So, okay, we're going to continue on. I have to stop the troll. I have to stop. I have to stop trolling trolls. Don't be trolling, because if you're gonna troll, you're gonna get cooked. Can the abacus use division? Yes, yes, yes. Well, you know what? Let's do that now. Let's do that now. Let's do a little bit of that. I like the color. Okay, good. You still haven't convinced me that you're not a troll. Okay. So what are we going to do? Okay, so let me show you how we can scale it. So here's the abacus. Here's the number. With this number, we're going to do 1,000. We do 1,357. That's what we're going to do. And what we're going to do is we're going to add 2,431. We have 2,400. I'm sorry. Add the 2. Yes, we can add the 2. We want to add the 4. We add the 4. How do we do it? Just like I taught you here, all we got to do is plus the 5 minus the 1. That's what we have to do. And then we can keep going. We can add the 3, and then we can add the 1. So my final answer is 3,788. That's it. So what we're doing is I can show you that we can actually scale it. Because we can scale it, it is a lot easier to understand how versatile the concept is. But the biggest thing is understand the concept. After that, we could do it again. If we have 26, you could do what mainstream math does. You could do finding friendly numbers. You could do 26 and then you can round up or whatever. You could do that strategy. That is up to you. But that is not what I do. Right? That's not what we do. What we do is we add the 3 and then add the 2. Can we take away the 3? We plus the 5 minus the 2. And then we want to add the 2. All we got to do is just add the 2. There we go. So my final answer is 58. You don't teach good? Okay, Nellie, then you can leave. You don't need to be here. I'm not here putting a gun to your head to stay in my class. Stay in my class, Nellie, or else you get banned. What am I going to do? Just leave. Just leave. If you don't like my teaching, leave. Okay, so what we're going to do, I understood it. See? Thank you. But it also depends on how far how long you've been here, you know what I mean? All right. Thank you, Thank you, Robert. That's okay. I get trolls. I like to cook trolls. Okay, so we're going to continue on. You know what? Let's do some multiplication. What are we doing? We're going to do some multiplication. Can we do it? Yes, we can. We can also do what? So we have multiplication. Okay. Now in Abacus world, what we do is we do distributive property. Because we do distributive property, it is a concept that you need to understand. That's all it is. So these are going to be very easy. You should be able to do these in your head, which is fine, but that's not the concept I'm trying to teach you. Because if I just showed you what was in my head, oh, hey, wait, you can't. You can't see what's in my head. You should be more friendlier, so I want to learn math. You know, Nellie, that's perfectly fine. If you don't like it when I cook trolls, I'm sorry, then you might be a troll. I don't know. You being live is tough, and I have a lot of trolls. When you add the 5 and subtract, would that be most likely simplifying? No, it would most likely be balancing the equation. Or else you could look it up somewhere else and learn there. That's very true. Thank you, Aaron. Yeah. Thank you, Aaron. Matt Mar. So really what we're doing is we're balancing the equation. That's what we're doing. Why? Because what we want to do is we want to have the 4. If we want to have the 4, it's the same thing if we did adding the 5 and minusing the 1. Does that make sense, Matt Mar? So what we're doing is we're balancing the equation. We can either do 4 plus 1 is equal to 5, or we could do 4 is equal to minus the plus the 5, take away the 1. Right? So when we're looking, we want to look at 4. And we want to add another 4. But I have no more loose beads. So if I have no more loose beads, right? Then what I got to do is I got to utilize the 5. If I utilize the 5, I have to remove the 1. Does that make sense, Matt Mar? So what happens, so it's not simplifying, it's balancing the equation. That's all it is. It's just balancing the equation. So when we're looking, we could do it again. If I have 4 on the abacus, I want to add 3. To add the 3, all I got to do is balance the equation. That's it. So what do I do? It would look like this. So if I have 4 on the abacus, right? 4 on the abacus, I want to add 4. No, I'm sorry, 3. We want to add 3, right? Sorry. 4, 3, right? But guess what? I have no more beads to add the 3. So I can replace this with a 5 minus 2. So now I have it like this. That's what I have. So 4, and then plus the 5, and then take away the 2. We could do that. I don't know if that makes sense. Okay. So, okay, calm down with the comments. It's okay. You can Where did the 5 come from? The 5 is the top bead, Nelly. The 5 is the top bead. So when we're counting, we do 1, 2, 3, 4, and then 5. That's what the 5 is, okay? When we look, we have 1, and we add the 5. Now we have 6, 5, 6. We have 2, we add the 5, then we have 7. We have 3, add the 5, and then we have 8. We have 4, add the 5, and then we have 9. And then you might be wondering, well, what about 10? 10 is this. This is what 10 is. 10 is a 1 and a 0. 10 is not this. 10 is 55. This is 55. 5 is 55. Every number is represented. So if I did this, this is 555. If I want to do 10, 11, 12, 13, 14. 100, 114. D-Pan. Are you serious? So when we're looking, every number is a column. This is what the columns look like. Every column has a place value. So when we're looking, we have 99999. 99,999.99. That's all we're doing. Every column goes up to 9. This is a decimal system. We're just working with decimals. That's what we're doing. So now, if I clear it, right, I have 100, 200, 300, 400. See, this 400 looks exactly the same as this, but on a different place value. This 4 is the same, but a different. When would I use this? If you want to keep your brain active, if you're like puzzles, if you want to strengthen your math foundation, because what we do in Abacus is we only do adding, subtracting, multiplying, and dividing. You want to keep your brain active. You want to talk about brain gymnastics. Or if you're young, you might want to have a stronger math. You want to have stronger math. So I'm not sure how old you are, but I know I have a lot of young kids. And because I have a lot of young kids, I still cook trolls. I'm just saying, I like to cook trolls. It's useful when you're buying groceries and trying to find. You're right. Absolutely, trying to find the best prices. The other one was counting calories. I had a whole list. Counting calories. And a lot of it's like comparisons. Helpful in high school. Is it helpful in high school? I wouldn't start it in high school. I think you've kind of missed the boat on high school. You can multiply and divide pretty quickly. Yeah. Um, I wouldn't, I don't know if I would start in high school because you're going to be more busy with school, high school stuff than you would be in anything else. You could start it when you're in elementary school or you could start it after college, is what I'm saying. Do you carry a pocket abacus when I go to shopping? No. No, unless I do, I do, I take that back. I do if I'm trying to create posts. That's what I do. You start remembering how to do it mentally. Yeah, there's a lot of people. Oh, what's crazy? There's a lot of adults that are getting into Abacus, which is really cool. You could do road trips, distance comparison charts. I think the comparison charts would be a good one, or even like understanding how to like the jobs. Like how much per hour on your or the difference between hour and then exercising and tracking your miles. Yeah, that that was for D-Pen. Oh. Well, no, D-Pen actually was one of my students of my school, and so D-Pen was probably has it in his have it in D-Pen's head. Yeah, it's a little tougher, but yeah. But then you get to a point where you can kind of see it. But when you learn it young, you'll be easy. It's a lot tougher for the old ones. Okay, D-Pen, thank you so much for dropping by. Thank you for so much. Thank you so much for dropping by. I'll let Miss Karen know that you said hi. How do you calculate 9,900 times 876 with your magic machine? I will have to change my magic machine. Let's do it. All right. Let's do some freestyling math here. All right. So the first thing we're going to do is understand our starting point. So the first thing we got to do is write down our numbers. So we have 900 times that by 876. What are we going to do? We're going to count the digits. Thank you, Chris. Thank you. It is 6. 1, 2, 3, 4, 5, 6. So then what are we going to do? We're doing distributive property. Because we do distributive property, all we got to do is 8 times 9. 8 times 9 is 72. Right? Thank you, Chris. 7 times 9. 7 times 9 is 63. Add the 6, add the 3. 9 times 6 is... What's 9 times 6? 9 times 6 is... Thank you, Chris. 54. It is not 48. 54. 1, 2, 3, 4. So what is my answer? So my answer is 7, 8, 8, 4, 0, 0. That's the answer. Yep. Thank you, Marlene. Thank you, Shai. So that's the answer. Easy. Why? Because in Abacus world we don't do 900 times 800. Why? Because on the Abacus we do it does it for me. So that's why I go here. 1, 2, 3, 4, 5, 6. I know I'm going to be having 100,000 in my digits, right? Chat help you. It doesn't count. What? That doesn't make sense. So when we're looking, right, we want to know how many digits we have. So we have our 900 here and we have 800 here. So that means we got to combine the two and we get 6 digits. Right? She's helping us. Yeah, she's saying you have to... She's saying we have you the answer. He forgot the comma. Whoa. Okay, got it. She's saying we have you the answer. Oh, I see. Wow, Nelly. Wow. Apparently you don't do a lot of teaching. I'm not sure Nellie is understanding the concept of magic machine, as she said. Sorry. So would this process change the two digits that weren't zero? You know, it would not change, Matmar. But the difference is now we have to actually understand the formulas that we didn't do. So there's formulas that we need to understand. We need to understand how to make a 10, and we need to understand how to make a 5. So when you know how to do this, then doing 3 digits times 3 digits becomes easier. The only thing you need to do on the abacus is you need to track the numbers. Maybe these people also need English lessons. That chat help you, so it does not count as you answering it. Huh. Okay. So, I mean, we could do that. We could do that one. 923 times that by 876. We could do it, but it might be a little bit too much. Nellie, do you even know how to do these? And the other question is do you even know how to read the abacus? So there's no point of giving me a harder question if you're not understanding the concepts that I'm trying to teach you.
Do you understand the words that are coming out of my mouth? Do you understand the words that are coming out of my mouth?
Okay, so then when we do 8 plus 8, right? 8, I want to add another 8. All I got to do is plus the 10 minus the 2, right? Okay, so then what do? If I want to do 9 plus 9, how do you add 9 to this number? Let me know. Because there's no point of me telling you. There's no point of telling you how to do something harder if you don't know the fundamentals, if you don't know the basic concepts. Oh, so Matmar, does that make sense? So when we're talking about it, we have different formulas. Some of the formulas there's only 2 sets of formulas you need to know. There's only 2 sets of, you said 9 was top. You don't, okay, Nellie, slow down and understand fundamentals. Can you explain the fundamentals? Yes, let's do that. I'm gonna just move on to going back. Yeah. So we have jins. Yeah. So we have 1, 2, 3, 4. That's the fundamentals, right? 1, 2, 3, 4. All the bottom beats is a value of 1. Anything touching the reckoning bar is considered counted. So what we have is 1, 2, 3, 4. The top beat is a value of 5. The 5 is here. So we have 5 and then we have 6. We have 7. We have 8. Does that make sense? So if I have 3, 1, 2, 3, I add the 5, we have 8. We have 4, 1, 2, 3, 4, we add the 5, and then we have 9. Does that make sense, Jin? So when we have 10, that's what 10 looks like, 1 and a 0. We have 15, right? 1 and 5 is 15, right? So then what does that mean? Well, every column is a place value. So we have place values. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. Yeah. So when we do this is 99,999.99. I understand, Henry. How do you do subtraction? Subtraction would be just the opposite. So we talked about how we added, right? We talked about adding the 4 to get the 8. Okay, that's fine. But now what do we do? To minus the 4, all we got to do is minus the 5 and plus the 1. Now you're seeing a number pattern. Oh yeah, not a problem, Sky. I enjoy trolls because it's just funny. I like I like the banter. It keeps me on my toes. So does that make sense, Henry? So when we're looking, right, we have a number pattern. And it's the same thing with the 3. I don't know if you were here for the adding of the 3. When we added the 3, what do? We have the 3 on the abacus. We added we added the 3. To add the 3, we plus the 5 and we take away the 2. So then my final answer is 6. So what do? We do the opposite. If I want to minus the 3, all I got to do is minus the 5 and then plus the 2. So my final answer is 3. I'm going to tell my teacher I did math on TikTok, so I don't need to go to class. No, Nellie, you need to go to your teacher and listen and pay attention in class, because I am not here to replace your teacher. There's no replacing here. This is just understanding, and you're not understanding this, so I would not pass you in my class. You would not pass my class. I'm letting you know. Okay, Jawa. So Jawa, when we do 1, 2, 3, 4, and then this is 5. Can you explain each color? It doesn't matter. The colors mean nothing. The colors mean nothing. So we have this. We have 1, 2, 3, 4, and then 5. So even if you're colorblind, you should still be able to do this. The reason why is because what? The reason why is because it's the positioning of the beads. Every time the beads are touching this reckoning bar, it is considered counted. So this is 5, this is 6, this is 7. Every time the beads are touching the reckoning bar, it's counted. None of these columns are counted. These are not counted. Then we have 8, and then we have 9. So 5 resets. Yes, exactly. So if I take away the 5, then we have 4. If I add the 5, we have 9. I don't think the colors mean. Oh, yeah. So the longer one, how would you determine where? It depends on the positioning of the marker. This marker tells me the ones place. In this one, I like to be in the middle, right? I like to be in the middle. So I have my ones, my thousands, my millions. Or I can do my decimals. I would have all of this to be my decimals. You won't, because you probably Aaron. Right. So then that's why I have this. I have my if Nellie is a child, I feel sorry. If Nellie is old, then I don't mind cooking. So the placeholder is here. Not placeholder. The label is here. This is the ones place, right? And then this is the thousands. So that's why I would do that. Does that make sense? Yeah. And then, so yeah, every column is a placeholder. Okay. So, Matt, did that make sense? We need to understand. Oh, so does that make sense with the subtraction? Okay. So now what we're doing here during competition, that's my kids act out. Yeah, that's why kids act out during competition. Okay. So here, what are we trying to understand here? We're trying to understand how to make a 5. Now, why are we going to do that? Well, if I have this, right, I have a 4. The reason why we have 4 is because there's not enough beads. So we have 4 on the abacus. For those of you that just joined, thank you so much for joining. Welcome.
Welcome to the real world.
Okay, so the first concept that we're going to do, is understand the 4. So we're going to add the 4. I don't memorize 4 plus 4. What we're going to do is we're going to utilize the 5. So what does that mean? We have this concept. 4 plus 1 is equal to 5. That's what we're going to do. 4 plus 1 is equal to 5. Because this is the concept, we're going to balance the equation. We want to add another 4. But guess what? We don't have enough beads to add another 4. I can give you a nickel, but because I give you the nickel, that's too much. 5 is worth, 5 cents, but that's too much. I need to take away the 1. So my final answer is 8. 5, 6, 7, 8. I could do it again on the abacus. I can add the 5 and take away the 1. Here's another way to see it. So here's another way. If I had 4 cubes on the abacus, if I have 4 cubes, it's very similar in counting in Japanese, I feel like. I don't know how to count in Japanese, but I wonder. Because this is a soroban. The soroban, this one is a Japanese abacus. So we have 4 on the abacus. If I have 4, I don't have any more beads, and I cannot do this. This would be 44. So what's going to happen is I need to add 4 to the ones column, but to add the 4 ones column, I have this 5. I have this 5. To add the 4, I have this 5. But guess what? The 4 cubes is right here. But because the 4 cubes is right here, I need to remove this 1. Because I remove this 1, I cannot take it away from the package. I need to take it away from here. Does that make sense, Jawa? So now my answer is 8. 5, 6, 7, 8. I can do it again. I can add the 5 and then take away the 1. So what we're doing is we're practicing the number how to add the 4. The 4 is what we're trying to understand, right? And that's all we need to do. Because why? Let's do another one. We have 3 on the abacus. We have 3 on the abacus. I want to add 4. But to add 4, I want to add, but I can't. So I need to give you this package, this brick of 5. 1, 2, 3, 4, 5. But that's too much. I get that. Okay, good. Okay, good. Can you show me a double digit? Yeah. So let me finish my thought. So I need to remove this 5, this 1, but to do that, I need to take it away. So I can do the same. Add the 5, take away the 1. So, Jen, I can do something better. Thank you, Chris. We can do a 4-digit number. Here we go. So here we go. We go 1,357, right? Easy. 1,357. What are we going to do? We're going to add 2,431. But if you know how to read the abacus, you'll know how to do it. Why? Because now you look, right, Madam G? Now you look, right? Plus the 2. Can you do it? Can you add the 2? Can you do it? Yes, you can. So then you have here, right? I want to add the 4. Yes, thank you, Marlene. Right? You want to add the 4. If you add the 4, hello, Big Al. Thank you so much. You want to add the 4. That's what we did here, right? We added the 4 here. To add the 4 is what? Plus the 5 minus the 1. And then we do what? We want to plus the 3. Plus the 3 is 1, 2, 3. Thank you, Ben. Yes, thank you. Yes, right? See, once you understand the basic concepts, then it doesn't matter. Right? Once you understand the concepts, it doesn't matter what column you're at. So then we have our 1. Add the 1. So my final answer is 3,788. And there we go. We can do it again. We can do 26 on the abacus. 26 on the abacus. I want to add 32. I don't need to make friendly numbers. I just need to know how to make it, right? I know how to plus the 3. How do I know to plus the 3? We know because we've done it. To plus the 3 is what? Plus the 5, right? How do we plus the 3? Plus the 5 is equal to minus the 2. So what do we do? 2. Plus the 5, take away the 2. Why? Because we're trying to add the 3. So I get the 5. And then we want to add 2. Add 2 like that. So my final answer is 58. I never understood abacus. You're welcome, Jins. Can you do... Yes! Yes! So now if you want to do... Wait. Can you just do 10 plus 7 so I can make sure of this? You could do 7. No, it doesn't matter. 7 doesn't matter. Why? Because if you add the 7, is enough. There's no formulas. You just add the 7. How long did it take you to completely understand this? Probably about 6 months. But I also went all the way up to multiplication and division. Like if you really went... I mean, and then... But then again, my primary was trying to teach. Right? So I had to understand what I was trying to say. To get to this point... Yeah, we could do that. Yeah, we could do that. We can do that in a little bit. If we want to add the 10, does that make sense, Jawa? It's practice versus practice versus practice. It is. It is. It's a lot about practicing. Okay, so we have... So 10 just looks like that. 10 plus 7. All we're doing is adding the 7. That's it. But we can do a next one, right? The next one is to make a 10. Making a 10. Making a 10, what are we doing? Well, what about... That's a good one. Yes. Would we carry the 3? No, 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 you don't carry the 3. Why? Because 8 is not the pair. The pair of 8 is not 3. How long have I been teaching? I've been teaching for about 20 years. Oh, I need... Yeah, anything that has to do with Abacus, like Abacus doesn't carry. Abacus carries the 10. That's what the 10 is. So here's the question, 8, right? So when we're doing it, we have to know that 8 and 3, 8 and 2 is a pair to make a 10. Does that make sense, Ben? So what are we trying to do? If I have 25 on the abacus, 25. It's a little different because we have to get that 3, we have to get a 2. Right? We have 25, but it's in here somewhere. We have to minus the 2. To minus the 2, I got to take this away. Right? Let me see. Let me see if I can do this. Let me see if I can do this. So, we have 25 on the abacus. The question is 25 plus 8. Here's my 8, right? I have 25 on the abacus. I want to add the 8. When I add the 8, I know I want to make... How do I make a 10 out of this? 10 is 2, right? 5, and then 3, and then I need 2 more for 10. But I don't have any more beads to make a 10. But guess what? I can take it away from here. I could take it away from this 5. But the problem is I have to break this 5 in order to add to the 2. So what do? I have to break my 5 like this. I have to break my 5. So I broke my 5, and what do? I have to take 2 away from here. I have to take the 2 away from here and add it to my 10. That's what I did. So I plus the 10 and then minus the 3. So my final answer is 33. I don't know if that was too much. So no, you don't carry the 3. You leave the 3 there because it comes from the 25. What we're doing is we're utilizing this to make a... Does that make sense? So this was, Chris, this is what we consider a 2-step equation. Because why? Because we had to break this 5. We have to break the 5 in order to make a 10. This is my 10. I wish this was taught in school. Oh, good. Yeah, it's coming together. It takes a little bit, but don't forget, it's only been here. Hello, Bear. It's only been here. I mean, you guys only been here for maybe an hour, maybe a half an hour, right? It's different than the way mainstream talks. Because what does mainstream do? Mainstream does counting up. Mainstream does memorization. This is not memorizing. This is understanding how to make things, right? That's what we're doing. Thank you, AJ, for the roses. Yeah. So what we're doing, and you could do it again. It doesn't matter. You could do it again. Here is another one. Here we have 7. This is a little bit easier, right? So we have 7 on the abacus, right? We have 7 on the abacus. I want to add the 8. To add the 8, this is what I do. I add the 8. Guess what? I need to make 10 right here. To make the 10, I have to take it away from the 7. So I'm rearranging it, and I'm adding it to this. So all I got to do is, but that's the formula, right? If I have 7, all I got to do is plus the 10. There's my 10. And I got to take away the 2. So that's what I did. I have 7 on the abacus, right? I have 7 on the abacus. That's my 7. I have 8, but this is kind of, I don't know. This is incomplete. I need to make 10 out of this 8. To make a 10, I take it away from the 7. And I add it to here. So now this becomes 8, 10. This becomes 10. So what do? I take away the 2 and I add the 10. That's what I did. I got this so much more easy. Yes. Yes. Because there's a path. Right? That's the problem, right? There's a path, but everybody wants to jump around. right? We could do it again. We could do it with a 7. What is the partner of 7? Who is the partner of 7? The partner of 7 is 3. So if I did 9 on the abacus, right? If I did 9 on the abacus, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I have 7. That's 7. Well, I want to make a 10 here. Yes, thank you, Chris. I want to use 3. 3 has to come from somewhere. 3 has to come from the 9. So I take the 9, I take the 3 away from the 9, and then I add the 10. That's all I do. Because I'm trying to make my 7 a 10. That's what I'm trying to do. Make sense? Thank you so much for liking the live. So what we're trying to do is we're trying to make a 10, but we're utilizing what we have. Thank you for the follow. Right? And we could do it again. But see, the difference in what? The difference in mainstream is that they go back and forth. Abacus, we don't do back and forth. We follow what we're trying to do. So here, if we did 8 plus 4, right? 8 plus 4. Well, that's fine. But no, mainstream would say what? Well, just make a 10 out of the 8. Well, that's fine. You can do that. But where are you going to get it from? You don't see where it's coming from. So why do that? You know what I mean? So what I want to do is I have my 8 on the abacus. I want to add 4. Okay. I know 4 is this. How do you make 10 out of the 4? So you should go from top down. It's always top down. Because if you start going up and down, then you get confused. Go top down. How do you make a 4? How do you make 10? So when you make a 10 out of this 4, what do? Yes, you take 6 away. You take 6 away from the 8. Just as Chris said, you take away the 6, like that. And then you add my 10. So my final answer is 12. Your abacus will show you the answer. You just need to know how to move it. You know how to move your beads, you will know how to find your answers. It's all about the process. It's not about the destination. What's the weird question? There's no weird questions. There's just questions of understanding. Hopefully it's an abacus question. Right? So my final answer is 12. So when I bring it together, it's 12. Right? So, and we can do it again. Can you do square roots on abacus? You can. I don't know how to do it because there's only so many square roots you need to do. So typing takes so long. You could dictate it. No, you could do square roots, but really what a square root is really you have to memorize. I wouldn't know how to. Somebody was able to figure out a way to do square root on the abacus, but I learned it, but then I forgot because it's just one of those things like I don't, because there's only so many square roots you need. And then you start getting to like decimals and stuff, it gets kind of crazy. Yeah, I have to be quiet. Oh, baby's sleeping. Oh, yeah. Yeah. Oh, I see. Yeah. Can't. Yeah. All right. Can't dictate. Yeah. Headphones. Yeah. As long as you're just made it click. I was trying to find the 10 on the bead vertical. Right. So the bead vertical is right here. That's what 10 is. So even if we had 12, right, plus 8, if we have 12 on the abacus. I want to add the 8. What are we doing? Well, we got to take away the 10, and we got to take away the 2 from the top and add it to my 8. So when I bring it together, it becomes 20 minus the 2 plus the 10. Made it click. I was trying to find, yay. So 0 would be the default. Yes, exactly. 0 would be default. Right? And that's the interesting thing, because in mainstream, they don't show you what 0 is. They have a whole unit on what 0 the hero is. But in abacus, for us, it is natural to see that it is reset. It is a reset. And then we also have placeholders. So if we go 10, we know that there's a 1 and a 0. This is a 0. We know that we have 100, 1, 0, 0. So the zeros are placeholders. So, and then the interesting thing is the kids that when they go through Abacus, they don't have to worry too much about place values because the Abacus does it already. There's some other Abacus that is horizontal, and we don't teach it this way because you don't read your numbers horizontal. Zero concept, I feel like using the abacus. This zero is a concept I feel like people using the abacus came up with. Zero is just a placeholder, right? We got to start from zero. We can't start from one, right? It's got to come from somewhere. So zero it just makes it easier. And I heard somewhere in the grapevine that the Indians actually created the zero. And it's just a placeholder. Right? So when we're looking, we could do it again. And so this is the thing, right? Once we understand the concept, then we can do bigger numbers. So we had that. So Matt had that one question. Just trying to find the question now. Okay. So let's see if we could do this now. So now you understand there's basic concepts. Now we can go into we can start going into something a little bit more interesting, like this. So the question is, so we have 923 times that by 876. We can do it now because now you understand the concepts. Right. I believe it was actually an Arabic concept first. Oh, yeah, probably. I don't know my number. Like, I know we do number rule, 6 digit. Thank you. 1, 2, 3, 4, 5, 6. We're going to take it really slow because it's late. It is 11 at night for me. All right. So we're going to do 8 times 9 is equal to 72. Right? Thank you. It's 2 a.m. Yeah. Yeah. If I make a mistake, please forgive me. So we have 72. Now, let me talk a little bit more about it. In Abacus world, we don't need to say 800 by 900. Okay? So what does that mean? Because the abacus keeps my number for me. See, it says 720,000. So that's what this is doing. In new math, they write it out because new math is on piece of paper. And then you have a whole bunch of numbers. I can't, right? There's a whole bunch of numbers. Okay? So then the next one would be 8 times 2. We're doing is distributive property. We have 1, we have 6. Right? Because it's what? 8 times 2 is equal to 16. Next one is 8 times 3. 8 times 3 is 24. Thank you. Thank you, Chris. Thank you, Sky. So I add 20. I add 4. Okay. What are we doing now? Well, now, thank you, Big Al, we have to cross that out. You're right. 0 was discovered in India in the 5th century. Oh, thank you, Robert. Thank you so much for the confirmation. You know what? I heard it from a comedian. Okay, so we got to recount. Why? Because we're done with the 8. When we're done with the 8, we're done with it. So we got to recount. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the first thing we're going to do is 7 times 9 is 63. Add the 6, add the 3. We're adding the 3. This is where it becomes complicated. Not complicated. This is where you really need to know your formulas. So I want to add the 3. Thank you, Big Al. So we add the 3 is equal to what? Plus the 10 minus the 7. So we minus the 7. Let's minus the 7 first. Minus the 7. We want to add the 10. Guess what? Cannot add the 10. What do? We know to add the 10 is plus the minus the 9 plus the 10. So minus the 9 plus the 10. That's our 3. 1, 2, 3, 4, 5. We added the 3 here, right? So then we do what? We stay here. So 7 times 2 is equal to 14. So we add the 1, we add the 4. Cannot add the 4. How do we add the 4? Plus the 4 is equal to plus the 5 minus the 1. Plus the 5 minus the 1. That's the 14. So then it's 7 times 3 is 21. Thank you, Chris. Yes. So now we add the 2, we add the 1. Add the 2. Can we add the 2? No. Plus 2 is equal to plus the 10 minus the 8. Minus the 8 plus the 10, right? And then here we want to add the 1. Okay, we're done. No, we have one more. So we're done with the 7. We have to recount. 1, 2, 3, 4. Thank you, Chris. So 1, 2, 3, 4. See, the process is the same. You just need to track your digits. You just need to track your numbers. So 6 times 9 is equal to 54. Add the 5, add the 4. 6 times 2 is equal to 12. Add the 1. How do you add 1? Add the 1 is what? Plus the 5 minus 4 and then plus the 2. We're still here. So then our final one is 6 times 3 is 18. Add the 1, add the 8. Add the 1, add the 8. So then I don't know what's my final answer. My final answer, oh, don't shake it. So my final answer is 708, 548. Right? So what are we doing? We're solidifying we're solidifying our concepts of how to add or how to do multiplication, and we're also solidifying our concept of how to add and how to add the 5 and how to make a 10 and how to make a 5, right? And so what happens is then we could do multiplication, because what is multiplication? Multiplication is just fast adding. It's a shortcut. So these concepts that I'm teaching you, this concept is a shortcut. Is it a shortcut? It is a shortcut because we don't need to count up. Yeah, I would call it a shortcut, right? So we have multiplication is a shortcut for bigger numbers. I lost my place near the end. Yeah. And so that's the thing is like you really have to track your numbers. Do you think Abacus would help higher levels? Yes, Abacus is the gateway to complex math. Why? Because what Abacus does is it provides a foundation, and then it unclutters your mind with all the multiple math addition, subtraction strategies that mainstream math is introducing. So there's a whole bunch of there's a whole bunch of strategies that's being used. But if you just boil it down to the simplest things, then you have more room for your brain to think about other things. Does it help for geometry and algebra? Abacus has some algebraic features, but concept-wise, Abacus doesn't have no help. Abacus is only for adding, subtracting, multiplying, dividing. The only thing that it does is it helps you really get a solid foundation of adding of your fundamental adding and subtracting, your fundamentals of math, your basic math. What about the Pythagorean theorem? That is above my pay grade. I don't even know what that is. Does that make sense? Oh, I don't know what that is. But yeah, like geometry, algebra, calculus, what Abacus does is it provides a foundation so it's easier for you to add and subtract, multiply and divide. It is up to you to understand the higher concepts because those are newer math. Don't forget, Abacus has been around since Mesopotamia, so that means they didn't have complex math. They just had business, right? So taking the limit as x goes to infinity would be on me. Exactly. You know, if you really think about it, doing this is already in your head. I just showed you the number. If you can do this in your brain, I'm writing this out so you guys can see. You're really doing this in your brain. And all you got to do is just put it on the abacus. The abacus really only shows you the number. It is just a number visualizer. Best stream. Thank you, me. It's just a number visualizer. That's it. Thank you, Chris. I don't know what the Pythagoras theorem is. Does that make sense? This is just to show you the number. That's all it does. That is all it's doing. It's just showing you a number. It's just showing you that what you can do. That's it. You are doing the calculations in your brain. That's why this is called brain gymnastics, because you're doing these concepts. You're doing how to 7 times 9 is equal to 63. We're learning and understanding this. We're knowing how to do, like, how to make a 10 and how to make a 5. That is what you're doing in your brain. The abacus doesn't do it for you. You just know what to do. Whoever trolls this live stream are sad. Yeah, thank you. I wish not. Oh, thank you so much. Best for you. Yeah, thank you so much, CZ. A squared plus B squared equals C squared. Oh, yeah. I remember that. Yeah. So, like, we do algebraic things like distributive property and we do long division, but other than that, abacus is not that. Did I cover division yet? No, I didn't. We can go into it, and that would be it. Yeah, are we ready for that? Yeah, I had a couple of trolls. It was fun. Process is so similar. Multiplication is like the next level. Oh yeah, not a problem. Process is so similar. So we did multiplication. Do we want to do more multiplication? We could do simpler multiplication. These ones you could do in your brain. I know you can do it. But we can what? We could try it. Let's do some multiplication. All right. Simpler. Yes, simpler. So here, again, we're going to figure out our starting point, right? So we have, what's our starting point? Our starting point is 3. How do we know? Because we know our question. Our question is 1, 2, 3. Do we start at the fourth column? No, we don't. Because how did you get 4? You're just counting your question. That's all. 1, 2, 3. Yeah, third column. Does that make sense to me? Yeah. Yeah. No. So in see, that's the thing. Like in mainstream math, they don't teach you to critically look at your question. Well, we can look at it and we could be like, okay, we're going to have somewhere around 3 digits. Somewhere around the hundreds. So then we're going to do distributive property. We do 3 times 7. 3 times 7 is equal to thank you, Chris. 21. Thank you, Sky. Thank you, me. Thank you, Marlena. Right? We had so now what are we going to do? 21. Our next one is going to be 5 times 3 is equal to 15. Thank you, Sky. So all we got to do is add the 1, and then we just got to add the 5. So what are we doing? We're really understanding our multiplication fact, our fact family, or multiplication facts. You really need to understand your multiplication facts. That's what that means. So my final answer is 225. 225. That's what the answer is. So this is easy, but I'm still going to go through it. So again, what is our starting point? Our starting point is 3. How do I know? Because I have 3 digits in my question. 1, 2, 3. 1, 2, 3. Now what are we going to do? We're going to do 5 times 1. 5 times 1 is equal to 5. Thank you, Sky. But now there's a problem. What is the problem? We got to make our double digit. Every time it's a single digit, you got to make it into a double digit no matter what. So it's just like time. Like look at the time. It's 11:26, whatever. So it's 11:02. If it's 11:02, right? It's not 11:02. It's 11:02. You got to remember that there's a 0 in front of it. So when we do our multiplication, we have to remember, this is what messes me up. Yeah, you have to remember if it's a single digit, you got to make it into this. If you think about it, a 0 looks right here, but we just don't write it out. Right? And so what we're doing is every time it's a single digit, you want to make it a double digit. So that's why we do 1, 2, 3. We go here and we add the 5. So I add the 5. Yeah. Why? Because we did 3. 1, 2, 3. 1, 2, 3. 5 times 1 is 0, 5. The 0 pushes the number to here. So you add the 5. And then our next one. 3 times 5 is 15. Add the 1, add the 5. Thank you for the rose. Thank you for the rose. Yeah. So the 0 pushes it over. Thank you, Chris. It is 65, right? 60, 66. Yes, thank you. Yes, thank you. 60. No, not 65. 60, 66. 65, 65. How do you read it when you're finished? How do I read my maze? It's late. It's late, Chris. How do I read what? The answer? 65. So every column is a placeholder. Every column is a place value. So we read it like that. We have our 1s and we have our 10s. And then we have our 5 and then we have our 5. So we have 60 and then we have 5. Does that make sense, Sky? So we can do 65. Comes down here. Yeah. Okay. So again, this is easy. This is easy. But it's the concept that we're trying to do, right? Because if you follow the process, well, we're in the 3 digits. So is the answer 230? No, the answer is not 230. Why? Because if we do 2 times 1 is equal to 2, 2 is a single digit. So you got to do 0, 2, 0, 2. Add the 2. And then we do it again. 3 times 1 is 3. 3 is a single digit. You got to go 0, 3. 0, 3. So my final answer is 23. I know it's the same, but I wanted to show you the concept. The concept is making sure you understand what the rules or the process is. That's what that means. So 23, and I go here. My next number is 3 digits. 1, 2, 3. 1, 2, 3. So what do? 3 times 4 is 12. Hello, 300. Yes. Add the 1. Add the 2. Then what do? 1 times 4. Thank you, Chris. What's 1 times 4? 1 times 4 is 0, 4. 0, 4. Thank you, Sky. So our final answer is 100. Thank you. 124. 124. And then we're here. So, and again, this is easy, simpler. Easy, simpler. Because why? Because we're still learning what the process is. 1, 2, 3. 4 times 2 is equal to 0, 8. 0, 8. So the 0 just moves. Yes. Yes. And it's the same thing with making a 10. Because if we add a 10, right, we had the same concept, adding the 10. So we had, remember this? The 10. So we have 9. 9. I want to add a 9. To add the 9, what do we do? 9 plus 9, right? What do we do? Minus 9 is equal to plus the 10 minus 1. So if you look, Marlena, right? Plus the 10, 1, 0. See how the 0 pushes it over? 1, 0. Plus the 10, 1, 0. And then minus the 1. So my final answer is 18. Yeah, yeah. So that 0 becomes very powerful. Oh, sorry. That 0 becomes very powerful. It either pushes your number over, or it just pushes your number over. Yeah. What's the point to know this? Brain activity, brain gymnastics, rock star energy cue. Because it's 0, yeah. Do you know? I don't know what's going on. What is the counting capacity for this specific one? 99,999. So, if I, did I do it here? I didn't do it here. No. So, for this one, it would be, yeah, there we go. That's the capacity. So, if we did this, right, we have 99,999 point sits between these two, right? 9, 9. That's what that would mean. Yeah. That's as high as this one goes. If you pay attention to the markers, right? I called this one to be my ones place. That's if you choose this to be your ones place. If you do it the other way, right? Then it would go like this. So then it would be 99.99999. You know what I find interesting? There's no comma for after the decimals. That's what I find interesting. Because it would be nice to know that this is ones, tenths, hundred thousands. It would be nice to have like a comma here. So I know that this is thousands. But whatever. But on the abacus you could see it. That's what that would look like. Yeah. So that is a little about multiplication. In the multiplying, you take it slow. That's not it. Multiplying. Where did I put it? Here it is. Right. So in what case would you use it? I'm sorry, I'm reading. So in so in that case, you could use it in a negative. Yeah, exactly. But see, what's a negative? When we write negative, we usually, even if it's a -5, right? Even if it's like that, you still do 8 minus 5. You know it's 3, but you need to remember it's a -3. So you still need to do it, but it's still in your head. The abacus would be the same way if it's like 8 times 5. Yeah. Yeah, I find it interesting in that commas can't be used for decimal because the number is getting smaller than larger. Yeah, but it's interesting that we don't have anything to signify the thousands. So if I had really small numbers, you would have to count it all in order to figure out where your number is, which is really interesting. Which is interesting. Since you're going the other direction. Yeah, yeah, yeah. Yeah, yeah. But it would be the same way like how we do it on paper. Because you can't really show a negative number on the abacus. So it'd be the same way how you do it on a piece of paper. The abacus is just there to show you, what the number is. It is up to you for you to remember the sign. Yeah. So we have our 8. So 8 goes this way. 80. And then we have our next number. So again, we're doing distributive property. All right. I think this will be my last one because I'm yawning too much. So we have 3, 1, 2, 3, right? Thank you, Sky. Right? Makes sense, right? 1, 2, 3. There's always a rhyme and reason when you do it on the abacus. There's always a reason why. That's how I feel it, and I like it because then it makes it more solid for me. So 9 times 3 is 27. Yeah. Oh, hey, Liz. Good. So we add the 20, we add the 7. Thank you, Liz. Right. Yeah, between my troll cooking. So then we do next is 2 times 9, right? 2 times 9 is 18. Add the 1, add the 8. Thank you, Sky. Thank you, Chris. Yeah, you don't have to write it out, but I do because I want to show you where I'm going. You know what I mean? So, thank you, Lady Gaga. Thank you, Lady Gaga, for the follow. Yeah. Oh, yes. Thank you, Marlene. Yeah. So our answer is 288. That's what it looked like. 288. So what do we just do is we're just putting numbers on the abacus. But then like I could do it without writing, but then you guys might get confused, you know? Because if I did this, I'm here, 1, 2, 3, 9 times 5 is 45, 9 times 2 is 18. But then it doesn't help for you to understand. That's why I write it out. Right? I'm not here to flex that I can do it. I'm here to help you understand it. I gotta learn this from scratch. This is so cool. Oh, here. Let's do a review. So we have 1, 2, 3, 4, 5. That's 5. Then we have 6. Notice that there's a 5 and a 6. Anytime the beads are touching the reckoning bar, that's being counted. So if we have 1, add the 5. That is 6. We have 2, add the 5. And then we have 7. We have 3, add the 5. Now we have 8. We have 4. That's 4. Notice that the top bead is not touching the reckoning bar, so it's not counted. So this is 4. When we add the 5, we bring it down to the reckoning bar. Now this is 9. Yes, the top bead is always 5. So 10 is not this, because this is just 55. 10 is exactly how you write. 1 and a 0. Okay, good night. Thank you. Oh my God, Chris, you're crazy. Yeah, have a good night. I'll see you in my next live. I don't know how you function with just 3 hours. That's so crazy. So that's what 10 looks like. It's a 1 and a 0. And then we have 11, 12, 13, and then 14. And then after 14 is 15. Thank you for this. Never understood these since they were never in my math classes. Yeah, this is not a common thing. I can't get enough of this. Oh, Chris, did I tell you about how to add the 10? Did I tell you this? How to add to 100? You could do that as did I tell you? You can add that as your part of your activities. Oh, maybe I should. Did I tell you this? No? Okay. So there's a little warm up. It's not a warm up. It's like a whole exercise. You add 1 to the abacus, and then you add, right? 1, and then you add 2. Add 2 to this. Add 3, so plus the 3, right? And then plus the 4. Plus the 4 is 10. And then what? You add the 5, so you get 15. Add the 6, you get 15, you get 21, right? Add the 7, add the 7. Add the 8, right? Does that make sense? Yeah. Try doing that. Your final answer, you go all the way to 100, your final answer should be 50, 50. Yeah, that's one of the exercises that other people were doing. If you wanted to practice. Yes, I'll get it. I'll practice. Okay, yeah. So yeah, and you go all the way to 100, and your final answer, so I'm letting you know, your final answer should be 50, 50. It takes a while. It took me probably about 4 hours, and then I made mistakes. You know what I mean? I made mistakes, so I had to backtrack. So it was a good practice and it was really kind of meditative. I'm not gonna lie. It was was good at math, but this looks like it makes it more fun. Yeah, the abacus makes it more fun, but you can actually visually see it. How long have you been using this or teaching this yourself? No, I taught. I've been teaching. I've been teaching abacus for 20 years. Yeah, thank you, Marlena. Thank you so much. Thank you. Between all of the what do you call it? Between all of the trolls. Some of the trolls are fun to play with. Some of them are kind of not. So, thank you for being patient while I go through the trolls. So, yeah, I've been teaching abacus for 20 years, and then I have books that are available to learn on your own, or if you wanted to if you have children, I do have books available, and they're activity based. And so this one, like color by number, mazes, and tic-tac-toe, and so forth. So I have activities situated all around the abacus. These are all abacus specific activities. This one is number 16 in my TikTok shop. And then I have if you know how to add, you will know how to subtract. So then we do a subtraction. So a subtraction is this one right here. Is it this one? Yeah, this is subtracting. So and again, these are a bunch of other activities. Will the preschool? Yes, yes. It will. Hello, fish guy. It will come, I think, this Friday or Thursday. So it's just a bunch of waiting. But yeah, I have the minus the 5, and again, it is activities with mazes and hidden words, word puzzles, word problems, and so forth. Yeah, yeah, it will come in stock this week for sure. I think Thursday was the shipment date, so we'll see, and then yeah, and then after that, you would learn how to make a 10. Thank you for the follow. Yeah, how about the Halloween one? Oh, I didn't think about stocking it because I thought it was too early. I was actually going to start bringing in Halloween. You're right. Halloween, if you're interested, I'll show you what it looks like. It depends on how old your child is. But this one was only counting to 10. This is really just only counting to 10. And I have like activities and stuff. So there's this, what do you call it? A clip card. And I had an example of a clip card. lost my example of the clip card. I had it, I didn't think I needed it, and now I need it, and I can't show you. But anyways, what it is you're supposed to cut these out. The Halloween theme is so cute. I'm thinking about getting it myself. Oh, oh, okay. Okay. But this is strictly just knowing numbers. So it is up to you, but it might be a little bit. This was I was thinking this was for more children, and so I have it where you find the abacus, and then you have a maze after the maze. So the idea for the maze is that you have to figure out how to find all the ones. It can either be the number one, the abacus one, the number one, or a blank square. If there's a blank square, the plan was that you would put Play-Doh into here. So it's supposed to be like interactive. And then from here, I color it in, and then I keep finding the number one. That's what that is. And then, but we don't do any adding and subtracting. I was going to theme it later. So this was scissors exercises, and the scissors exercises was meant to get them to practice their fine motor skills. And then here's the matching, and again we do some line tracing, and that's it. It's up to you. It's up to you. But this is very like just number recognition on the abacus. So this was like the cut, and then they have to match the pair. So if it's 1, this is 1, and they'd have to put it here. Yeah. Here is again, you would have to match the number with the abacus, the house, the abacus house, and yeah. It's up to you. And then there's this clothespin activity where you cut, and then you have to tell me, well, what number comes before and what comes after. I teach TK, and I'm thinking about these for the math centers. Oh, okay. This one might be more beneficial for your math centers, the Halloween one. And so this one was talking about comparisons. This one was bigger or this one was bigger, but you'd have to figure out, right? And put the dough ball. Again, there's more dough balls. And then I give you answers in the back of the book, just in case. So like this one was like, which one is more? This one's, yeah. Yeah. So this is the one with the pairs. That's what the pairs would look like. Oh, you can't see that. There you go. There you go. So yeah, there's the answers. Oh, good. Yeah. So I was trying to make it more like that. And then I was going to do more. I was going to build it out, but I have a lot of activities. It's just I got to take the time to format it and get it all ready. That's what I got to do. So that's what I got. So then, and then there's the Christmas one too. Christmas. Oh, Lady Gaga Christmas. What might be interesting. Because Christmas, you do a little bit of adding and subtracting, but it goes only into the simple stuff. So the question is like, I have 5. Do I have enough to add the 2? Yes. So you do it, and then you write the number here. Oh, that's what I got to do. I have to update this. So this is just a flip through of the Halloween, the Christmas one. The Christmas one is going to come up pretty soon, so I got to put that in stock. But this is what it would look like when when the maze is done. But again, this one is bead recognition, some cutting, and then afterwards matching here. Oh yeah, I like this one. This is the puzzle. So the answer is find the number between on the board. So you figure this out. So there's 1, this has to be 2, and this is 3. So then you have to find 2 in your puzzle piece. So there's 2 right here. Yeah, I like the puzzles and just trying to find it, a different way to get a concept. And so the page is blank in the back because you're cutting here. So you find the answers that's on the puzzle pieces. And then this is adding. So we go all the way to 9. I think we go all the way to 9. We might go to 10. Yep, we go to 10. Sorry, I take that back. We go all the way to 10. And then we talk about double digits. And then this is just print out. and then this is match the star. So they have to cut, and then they have to match the star to, they just have to match the star. And adding, subtracting, yeah, there's adding and subtracting, and again, there's more activities for the matching and tracing. Yeah. Oh, thank you, lady. Huh. That's what I got. Oh, so this one is, what's the number that comes before? So this is 15. I need to find 14, right? So I have to find 14. And then that's it. So there's just a bunch of more stuff. This one was like, obvious. And then there's the answers in the back of the book. Just in case I didn't explain it well, there are answers in the back of the book. Yeah. So these will be coming in as well. I was going to, this will be my first year selling during the holidays. So we'll see. I'm not sure. I'm not sure if I'll be able to make any more Halloween that can go into adding, subtracting, multiplying, and dividing. Because I need to fill out the others. So, yeah, that's what I got. And then the 10, after the 10 is minus the 10. And that's it. If you know how to add, you know how to subtract. That's what I have right now. I am working on my next book, which is talking about a two-step equation. Two-step equation means that we're going to be combining our information, our knowledge of how to make a 10 and how to make a 5. And that's another book in itself. So these ones were meant for kids that are coming out of preschool to go into this. So after this, they can actually go into multiplication. They can go into multiplication. And then when they figure out multiplication, then they can start doing division. So that's the plan. But it just takes time to go through it all. It just takes time to produce the activities. Yeah. This is also a bundle. But yeah. Thank you. Thank you, Lady Gaga. It's so sexy. That's what I got. So that's what I got. And I am gonna sign off. It's a little bit, I am getting tired. But yeah, that's what I got. And so for those of you that are interested, I do have books there, or I have my books over here. If you're also interested, I also have another video platform. But that's kind of like where everything is held. For those of you that are interested, my name is Lynette, and I also have my collection is over here. Yeah, thank you for oh yeah, not a problem. Not a problem. Thank you for thank you for sticking around and understanding something different. Thank you so much. Welcome.
Welcome to the real world.
I am showing the Matrix what the Abacus is all about. I hope you enjoy it. I'm happy that you guys were able to understand, just a little bit that's here even still, you know what I mean? Because to understand the power of the abacus, it's just amazing. The littlest thing, to just see your numbers, you can do so much. It's just crazy. It's crazy that you can do so much for just seeing your numbers. And I don't know why we push the kids to do everything mental anyways. I mean, I still write out what my to-do list is. I still write out, you know what I mean? So it's interesting. We don't do it in life. Why are we pushing in math? There's a lot of things we do in math that I don't know why we do. So, but yes, I am going to head out. Thank you again, everybody, for joining. Thank you so much for joining. It was it was fun. There was a kind of a, not too many trolls, but it was all right. Thank you. Thank you for the follow. Thank you for the follow. So, yes, have a good night. Oh, have a good night. Thank you. Thank you, Fish Guy. Later, be good. Yeah. Not a problem, Joseph. I'm so happy you understood. Okay. That's it. That's my cue. Thank you, everybody. Thank you. Have a good night. Have a good morning. Have a good day. See you later, everybody.